Hello explorers and welcome to another video. Today I'm going to talk a little bit about lambdas. And lambdas is something that was introduced in Java 8 and is a pretty new concept where you take some fundamental concept from functional programming and put them into Java in order to write probably less code and make things a little bit more understandable, hopefully. So you will be able to write a little bit less and reuse a little bit more, and hopefully it will be easier to read, at least if you understand these functional bits. So let's start with a pretty simple example here. We have a math operation defined here. And in this case I have an addition, and then I print a result with a function that do math. So let's look at my do math. It takes two input variables, it runs the math operation, and it returns the result for this operation in the math operation. So math operation is defined as an interface with only one function, and it could return whatever, and it could have as many inputs as you like. So that is not anything that it cares about. The only thing Java cares about is that you have an interface with only one function in order to use lambdas. And here I have my private class where I implement this math operation, and I override the function of operation and add the two values, and this makes it possible for me to actually do this without lambdas. So this is an example of you doing the same kind of work without lambdas, and it's a little bit of a contrived example because I'm gonna change this to lambdas so you can see how much less code is actually involved. So if we run this, we should get the result. Oh, I run the wrong function. We'll come to that later. We should get the result of 2. Now let's start to change this up a bit and make it less code. So we could do something like this, where we create a new math operation up here and we implement the actual function here, because it's so easy that we don't really need to have that much code. Okay, we need semicolon as well. So now we have 2 again. Then we could actually remove this private class down here because it's not needed for this. But this is still quite a lot of code just to override this function. So let's see here, if I remove, let's say, this part up here like this, and then I put this notation here and remove that, this is actually the same. So I removed a lot of stuff, and the only thing I have left is the inputs that I defined as ints and the return value that I want back inside of brackets. And if I run this, I still get 2. So now I'm starting to use lambdas. But actually, this return value, it's not required if we remove these brackets as well. So the brackets and the return value is not required if I only have one statement, because Java could actually figure that one out, so that you don't need to write that code. But you say these ints here, those are defined in my interface, so those shouldn't be required either. And you're right, I can remove those too. So now I actually have a math operation that is very, very little code that tells us what we send into this operation here and we can do math in our little function. And we can also reuse this. So let's say that I have a few operations here. So I can have add, subtract, and let's say divide. So then I just add, subtract, and divide. And or perhaps multiplication would be more sufficient, because divide could be a bit strange with some values. So if I send in sub instead, I should get 0. And if I use multiplication instead, I get 1. So this is a pretty easy way to write a lot of different code and replace stuff in your code. So let's go to the next little invoice example I have here. And this is something that I can write quite often, that I want this a few file in my case here with a few invoice rows, and I have a lot of other information in this as well, but I have invoice rows, and I have a product ID, a description, quantity, and unit price. And I want to print this information in this file. And what I do here, I start by actually reading the file, a few JSON, and then I fetch an array. So I get the invoice rows array, and for every element in this array, I change the type of this, because in the JSON array you actually get an object in the array. So you can't really fetch a JSON object. All objects in the array are just simple objects, because you can have an array that has strings or ints or longs or doubles. So I need to cast this to an object, and in my object I know that I have a unit price, and in this case I don't want the really low products, the low value products, so I will remove everything that have a price lower than $10. And then I will create my list here. I create a string builder, I append a lot of stuff to that to get my output, and I print out my string. So this work I have up here is just to actually print that data. So let's look at a functional way to do this. And I have this down here. First off, I wanted to have a print function that actually takes my JSON object here and converts it to a string. So I will have this print data where I send in my JSON object, I fetch each of the elements here, and then add some extra information. And this will convert something from a JSON object to a string. So I have a function here that takes some input and returns some output. So it's a function from something to something. And then I actually need to do some conversion first. So in my case here we have this JSON array, and I create a stream of that JSON array, which I map each object to a JSON object. This means the first part we had in our for loop, where we took the object in the for loop and changed it over to a JSON object. And when I do this conversion, I actually get a stream of JSON objects. And then I can take this stream of JSON object and do a filter operation on it. And a filter operation is something that takes a thing called a predicate, and this predicate has some input and returns an actual boolean in this case. So it's from something to something again. But a filter function requires that you give it an object or something from a list, and it will filter out everything that is not true in these predicates. So in this case I give it a predicate of get the double unit price and check that it's over $10. So everything over $10 will be added to my list or will be kept in my list, and everything below will actually be removed. So everything below $10 will not continue in this stream. It will not be streamed through. And then I have this map function, and a map function takes this function declaration I have up here and does the actual mapping from the JSON object to string. And last, I do a for each, and for each takes every value in my stream and does an operation on that value. And in my case, I have mapped it already to strings, which means that I can for each over these strings and print them out using the standard system out. And in this case, I take the static value print line. So system out, the static function print line, I will use that as a function that I give to the for each, and the for each will loop over all of my strings and print them out. So this wasn't that much less code, but perhaps it's more readable. And the sad part is this part here where I have to do the conversion, and I actually need to save a different stream after my conversion in order to stream over that. One would think that I could actually continue here and do the filter directly on this, but in this case, when I do the filter after my map, the actual types will not have changed inside of the stream. And another thing that you can do, if you like, is that you could collect to a collection, and you can also collect to, let's say, to list. So if you do a collector to collect to a list, you can actually assign this to a list of strings, for instance, if you want to continue working with this later on. So you don't want to use the strings right away. You can actually use a collector to collect all the values that you have streamed through and put them in a list so you can do other stuff with them later. So this is pretty much what I wanted to go through today. Talk a little bit about lambdas and how you define your own lambdas using interfaces. I've also talked a little bit about functions and how functions takes an input value and returns an output value. I've talked about predicates and how these could be defined as taking a value in the stream and actually returning a Boolean to actually do a test or check if this is a correct value. And I've talked about maps, filters, and the collect function, and also how to cast a stream of objects to another stream of objects. I hope that you found this video informative and that you learned something today, and I hope that you subscribe to see more videos like this. Like the video, hit me up down in the comment section if you have any questions about this, and I really hope to see you in the next one.